In question number 25, let's see that. Find the currents through the resistances in the circuits shown in the figure 45E3. These are the resistances and we need to find out the current flowing in these resistances. Before we do that, we should also read this. In problems 25 to 30, assume that the resistance of each diode is 0 in forward bias and infinity in the reverse bias. So typically these diodes have some forward voltage bias like 0.7 volt, and in special kind of diode like Schottky diode they have a lower drop of, or like a germanium diodes have 0.3 volts or something. They have some diode, but for the sake of simplicity, if they are in the forward bias, just assume that they have 0 ohm, that they are simple wire. And in case of reverse bias, just assume that they have infinite current. So let's do it one by one. In the first problem, this is a positive terminal connected to this diode, and this diode, this positive voltage, and this is negative voltage. So there is a positive and there is a negative voltage here. That means both these diodes in series, both of these diodes will be forward biased. And when both the diodes are forward biased, let's draw this because we have to do other problems as well. So both these two diodes, they are forward biased, and then we have the battery 2 volt and the resistance is 2 ohm. So these diodes are forward biased, so we can replace this thing as a simple 0 ohm resistor with 2 volt battery and 2 ohm resistor here. And in this case, the current I is equal to V, which is 2 volt divided by R 2 ohm, or 1 ampere. Now in the second one, we'll do it actually quickly because these are simpler problems. So in this one is in the forward direction, the other is in the reverse direction. So the voltage across this is trying to be so let's say this is forward bias, so we can just remove this diode and place it with the wire. But there's a positive in that case. There is a positive voltage here and there is a negative voltage here. So this means this diode is reverse bias. When this diode is reverse bias, so this circuit acts like an open circuit because at this particular point, and therefore the current in this circuit is 0. That is the part 2. In part 3, well, there's a positive voltage here and there's a negative voltage here, and this is true for this diode as well as this diode. So this diode is forward bias, so we can replace it with a simple wire with 0 resistance. This diode is also forward bias, so we can replace it as a 0 wire. So 0 ohm and 0 ohm, actually one is sufficient, so 0 ohm and 0 ohm in parallel is 0 ohm. And therefore, there will be a flow of this current, and the current will be given by I is equal to V divided by R, or 2 volt divided by 2 ohm, or 1 ampere. So this answer is 1 ampere. So I won't draw anything, but it's simple. So you can write it, the answer something like this. This is diode here, this is voltage, this is resistor. So we can replace it as simple as this resistor, this thing. These are in forward bias, 2 volt, 2 ohm, I is equal to 2 volt divided by 2 ohm, or 1 amp. In the third problem, one of them is forward biased and the other one is reverse biased. So the circuit is like this. This is like this, and this one is like this. This is 2 volt and this is 2 ohm, this is 2 volt. Very simple problem. So this one is forward bias. So if I do this, then there is a path for this, that because of this diode, this is forward bias because there is a positive voltage on this end here and the negative voltage on this end here. So this one is forward bias. The other one is open. If I could draw it as a switch, then this switch is open because this one is negative voltage here and this one is a positive voltage here. So this one is reversed bias. This one reverse bias is open. So when this is open, the circuit has a path to move. 0 ohm and this is infinite ohm is equivalent is a 0 ohm resistor. So the current in this case will also be 2 volt divided by 2 ohm, or 1 ampere.